Let's use this investigation to illustrate direct proportion. Our focus question is, how does number of coils affect electromagnet strength? Our apparatus includes nails, insulated copper wire wound around the nail and connected to the two terminals of a battery. That converts the nail into an electromagnet, and so it becomes magnetic while electricity flows through the circuit. And we can detect that fact by, for example, this electromagnet picking up some pins. And the stronger the electromagnet, the more pins it will be able to pick up. So we have a few of these electromagnets, and they differ in number of coils. So maybe we have one which only has 50 coils, another which has 100 coils, and another which has 500 coils. Obviously here in my picture I've shown very few coils, but that was just to simplify the picture. And then we want to see, how does that difference in number of coils between the different electromagnets affect their strengths? And we use the number of pins that they pick up as an indicator of that strength. Here we have some partial data from this investigation. X, which is the independent variable, is number of coils in the electromagnet. We make that to be different between the different treatments, from 25 coils to 400 coils per electromagnet. Then Y is our dependent variable. That is different between the treatments because we treated them differently. In this table, only some values for Y have been put in, and your task is to try to fill the rest in by seeing the pattern. If you can already see the pattern, then you might as well pause the video right now and complete this table, and then you can listen to the rest after that. If you can't yet see the pattern, let me help you to see it. Notice that between this electromagnet and that one, we have double the number of coils. 25 times 2 equals 50. And because of that, the second electromagnet can pick up double as many pins as the first. 1 times 2 equals 2. Let's compare the second and third electromagnets. Similar situation, 50 times 2 equals 100, 2 times 2 equals 4. So the third electromagnet has double as many coils as the second, and so picks up double as many pins. Let's compare the first electromagnet to the third. 25 times what gives you 100? 100 divided by 25, and the answer is 4. 25 times 4 equals 100. 100 is 4 times bigger than 25. And 1 times 4 equals 4. 4 is 4 times bigger than 1. So by increasing the number of coils fourfold, or by a factor of 4, the strength of the electromagnet also increases by a factor of 4. Let's compare, let's say maybe the third to the fifth electromagnet. Again, we have a doubling from 100 to 200 coils. And we have a doubling of the number of pins it can pick up. 4 times 2 equals 8. Another doubling over here, 200 coils to 400 coils. Again associated with an outcome doubling from 8 to 16 pins. How about if we compare the first and the last readings? 25 times what gives you 400? 400 divided by 25. The answer is 16, which causes 16 times increase in the number of pins which can be picked up. 50 times what equals 400? 400 divided by 50 equals 8. 400 is 8 times greater than 50. So this electromagnet can pick up 8 times more pins than that one could. 2 times 8 is 16. I hope by now you've seen the pattern. Complete the gaps in the Y column and then unpause the movie. Another pattern you can notice in this data is the ratio between X and Y. X divided by Y in all cases gives you a constant number. In this particular setup, that constant number is 25. 25 divided by 1, 25. 50 divided by 2, 25. 100 divided by 4, 25. So if you haven't yet seen how to find the missing numbers, you can use this method to do so. 150 divided by what gives you 25. 200 divided by 8 again gives you 25. You need to complete those ones. 400 divided by 16, 25. So here we have the missing numbers. So let's look at some patterns in this. For example, 100 times 3 equals 300, just as 4 times 3 equals 12. 150 times 1 1/3 equals 200, and 6 times 1 1/3 equals 8. As x is increased by a certain factor, y increases by that same factor. X divided by y gives 25 in this case. So the ratio between x and y is constant. Y divided by x would also always give a constant. It would be a different constant, of course. It wouldn't be 25, it would be 1 over 25. Let's use that data to plot a graph. Pause this movie while you do that. Notice that the points fall on a straight line. These are, of course, idealized values. In reality, you would very rarely get all your points falling completely on a straight line. You would get some a little bit above and a little bit below, and you'd deduce that it's a straight line relationship and draw a trend line. But these values were specially created to try to draw your attention to the pattern. That's why it's so simplistic. Now remember that we found that the ratio between x and y is constant. X is always 25 times greater than y. Put another way, y is always 1/25 of x. And that ratio corresponds to the gradient of this graph. Gradient means rise over run, change in y over change in x. Gradient means the steepness of the slope. Y over x in this particular data we have is 1 over 25, and we can see that that is indeed the gradient of this graph. So let's maybe, for example, take the entire triangle given by this graph, and we can see that the change in y is 16 minus 0 equals 16. That's the rise. And the run, or the change in x, is 400 minus 0, which is obviously 400. So we have 16 divided by 400, which is 1 over 25. Let's take a smaller triangle. Let's take that one over there. So we have the rise 12 minus 4, which is 8, and the run 300 minus 100, which is 200. 8 divided by 200 is 1 over 25. Pause the movie while you answer these questions. Once you've done so, unpause the movie to see suggested answers.